The James Webb Space Telescope has delivered the clearest image yet of Proxima B, offering unprecedented insight into this potentially habitable exoplanet. This groundbreaking discovery invites us on a thrilling journey into deep space as we unravel the secrets of Proxima B and explore the possibility that it could be humanity's next Earth, a world we might one day reach across the cosmos. Orbiting within a habitable zone of its parent star, Proxima Centauri, Proxima B is anything but ordinary. Located just 4.2 light-years away, this intriguing planet remains cloaked in mystery and fascination. Could it be a second Earth, complete with oceans, atmosphere, and even life? Intriguingly, Proxima B isn't alone. Another planet, Proxima Centauri C, shares the same stellar neighborhood, and there may be even more undiscovered companions in this nearby system. Proxima B receives roughly the same amount of stellar energy from Proxima Centauri as Earth does from the Sun, a tantalizing hint that liquid water and possibly life could exist there. As we continue to explore exoplanets, worlds that orbit stars beyond our own Sun, we enter a vast and varied cosmic landscape. With over 200 billion stars in the Milky Way alone, the possibilities for Earth-like planets are virtually limitless. Some exoplanets even roam through space unattached to any star, drifting as cosmic nomads. Yet among all these distant worlds, Proxima Centauri B stands out. It orbits its star at a distance much closer than Earth does to the Sun, completing a full orbit every 11.2 Earth days. This proximity results in one side of the planet being perpetually sunlit, while the other lies in constant darkness, a phenomenon known as tidal locking. To better understand Proxima B, we must also explore its host star, Proxima Centauri. This red dwarf star, also known as Alpha Centauri C, is part of the Alpha Centauri triple star system, alongside Alpha Centauri A and B, a binary system and the third brightest group of stars in the night sky. With a combined luminosity nearly 2.7 times that of our Sun, Proxima Centauri itself lies about 0.21 light-years from the binary pair and, true to its name, is the closest known star to Earth. Discovered in 1915 by Scottish astronomer Robert Thorburn, Proxima Centauri has an apparent magnitude of 11.13, far too faint to be seen with the naked eye. Despite this, it remains one of the most compelling objects of study. Red dwarfs like Proxima Centauri are incredibly efficient, producing modest energy but burning for trillions of years due to their fully convective interiors. Proxima Centauri is expected to remain on the main sequence for another 4 trillion years. However, red dwarfs also pose serious challenges to habitability. Proxima Centauri is a flare star subject to powerful and frequent bursts of radiation. Its habitable zone lies extremely close to the star, estimated between 0.023 to 0.054 Australian dollars, making any planet within it vulnerable to intense ultraviolet and X-ray radiation. Proxima B, for instance, may experience radiation levels far exceeding those on Earth, which could strip away light elements like hydrogen, nitrogen, and oxygen, critical components for a stable atmosphere. And that's a crucial point. Being in a habitable zone doesn't guarantee habitability. Without a thick, stable atmosphere, Proxima B would struggle to maintain surface temperatures conducive to water or life. It would also be highly exposed to space weather, making its environment hostile. Despite appearing Earth-like in some respects, Proxima B may ultimately lack the conditions necessary to support life. Still, scientists remain intrigued and cautiously optimistic. One of their most powerful tools in the search is the James Webb Space Telescope. Launched in 2018 after years of anticipation, JWST has revolutionized our ability to study distant exoplanets like Proxima B. It may one day help us determine if life, however simple or alien, could exist on this fascinating world. But the mystery remains unsolved. As we push the boundaries of exploration, the story of Proxima B is still being written. Scientific exploration always comes with challenges. To ensure the James Webb Space Telescope JWST could deliver highly accurate images, many precise adjustments were required. As astrophysicist Abby Tabor from Harvard points out, if a planet like Proxima B can absorb light from its star, it can also emit that energy as infrared radiation. The JWST was specifically engineered to detect this kind of infrared light, enabling it to capture images of such emissions from the planet's surface and search for telltale signs, such as water or atmospheric patterns. However, the mere presence of an atmosphere doesn't confirm habitability. Astrophysicist Ed Turner from Princeton University emphasizes that Proxima Centauri B could have an atmosphere as thick as Venus's, which would likely create extreme, life-prohibiting temperatures. Unraveling the secrets of Proxima B is no easy task. While the JWST opens new doors, numerous hurdles remain. Rising costs and technical limitations add pressure on scientists to innovate new methods for studying planets like Proxima B. Despite these obstacles, the potential payoff is enormous. The opportunity to explore new worlds and uncover the mysteries of distant planets is a pursuit that continues to drive space science. Proxima B's allure lies in its proximity. It's the closest known exoplanet to Earth, making it feel like part of our cosmic neighborhood. Even more intriguing is that Proxima B is nearly Earth-size and orbits within its star's habitable zone, raising hopes that it might support life-friendly conditions. Although we can't reach Proxima B just yet, it remains a prime candidate for future exploration. Advancements in technology may one day make such missions possible. Currently, a spacecraft like Voyager 2 would take around 75,000 years to reach the Proxima Centauri system. But a revolutionary concept, solar sails, offers hope. These ultra-thin sails could harness the pressure of sunlight to propel spacecraft, bypassing the issue of fuel depletion. This cutting-edge technology might one day allow us to visit Proxima B and study its environment firsthand. Still, limitations persist. Even with an atmosphere, Proxima B could resemble hostile worlds like Venus rather than a habitable Earth. The JWST can detect infrared emissions from Proxima B if they reach just 5% of the brightness of its daytime side. While that number may seem small, it's significant, especially considering Proxima Centauri is much dimmer than our Sun. There's also speculation. If advanced civilizations existed on Proxima B, they might use massive orbital mirrors to reflect light from the day side to the night side. Fascinating, isn't it? Our universe is filled with countless exoplanets of all shapes and sizes. Some are massive gas giants like Jupiter and Saturn, but even larger, these so-called super-Jupiters dwarf anything in our solar system. Others, known as hot Jupiters, orbit dangerously close to their stars, scorching at temperatures hot enough to melt metal. Imagine witnessing the fierce storms and blazing conditions on such a world. Beyond the gas giants, we find Neptunian exoplanets, similar in size to Uranus and Neptune. These include hot Neptunes and smaller variants that hug their host stars tightly. Their atmospheres remain largely mysterious, often difficult to analyze from afar. And of course, there are the Earth-like exoplanets, the ones that truly spark our imagination. Could one of them be another Earth, waiting to be found? Exoplanets, worlds beyond our solar system, often resemble Earth in many ways. They vary greatly in size, from smaller than our planet to more than twice its mass. Among them are super-Earths, which are more massive than Earth, but lighter than Neptune. One of the most intriguing recent discoveries is Proxima Centauri B, a super-Earth orbiting the red dwarf star Proxima Centauri. With an estimated mass around 7 times that of Earth, Proxima B lies relatively close to its star, though still outside the traditional habitable zone. Proxima B isn't alone in its system. It shares its neighborhood with Proxima Centauri C, a more distant planet with an orbital period of roughly 5 Earth years. This planet was identified in 2020 using archival Hubble Space Telescope data. Even more fascinating, Proxima Centauri C may be exceptionally bright, possibly due to a large ring system encircling it. In 2019, astronomers observed a shift in Proxima Centauri's radial velocity, hinting at the presence of yet another planet, tentatively named Proxima Centauri D. If confirmed, this planet would be about the size of Mercury or Mars, adding another chapter to the rich story of this nearby system. Imagine a universe where the night sky is filled not just with stars, but with countless unique planets, each with its own atmosphere, orbit, and potential for life. We're living in a golden era of discovery. Though we don't yet have a complete count of all exoplanets, we know they exist in staggering numbers, just like the stars they orbit. Studying exoplanets is no easy task. Many are hidden by the intense glare of their host stars, making them difficult to detect. Yet with cutting-edge technology, direct imaging has become possible. For a planet to be imaged directly, it must be large enough, distant enough from its star, and young enough to still emit detectable heat. While these criteria narrow the pool of observable exoplanets, they give us unprecedented glimpses into the makeup of distant worlds. Most exoplanets are discovered by observing how they influence their host stars. One technique, radial velocity detection, measures the subtle wobble in a star's motion caused by the gravitational pull of an orbiting planet. Another powerful method is the transit technique, popularized by the Kepler Space Telescope, which detects tiny dips in starlight as planets pass in front of their stars. This method has helped astronomers determine the size, distance, and temperature of many exoplanets. Here are some fascinating facts. Over 22% of Sun-like stars are believed to host Earth-sized planets within their habitable zones. The TRAPPIST, one system alone, contains 7 rocky exoplanets, several of which may have liquid water. Some exoplanets may also host exomoons, similar to the natural satellites in our own solar system. With more than 4,000 confirmed exoplanets, astronomers are just beginning to understand the vast diversity of planetary systems. While hot Jupiters, massive, fast-orbiting gas giants, are among the easiest to detect, a wide range of smaller and more temperate planets await discovery. The James Webb Space Telescope, JWST, is revolutionizing our view of the cosmos. With its powerful infrared capabilities, JWST has been capturing breathtaking images and collecting groundbreaking data. Recently, it made history by detecting carbon dioxide in the atmosphere of an exoplanet, the first conclusive evidence of its kind. This gas giant orbits a sun-like star 700 light-years away and offers critical insights into planetary formation and atmospheric chemistry. According to NASA Administrator Bill Nelson, this finding offers a completely new perspective on the universe, energizing scientists and space enthusiasts alike. JWST has also been instrumental in projects like the Ice Age Survey, which explores how cosmic ice forms and evolves into comets. One striking image captured light from a young object called IRAS 110, illuminating icy clouds and revealing background stars obscured by cosmic dust. In another milestone, JWST successfully imaged the inner regions of a dusty disk around a nearby red dwarf star, capturing these features in infrared wavelengths for the very first time. As we push deeper into the cosmos, each discovery reshapes our understanding of the universe and our place within it. The age of exoplanet exploration has only just begun, and the possibilities are limitless.